have really solid data to suggest that there is an ocean underneath that icy surface. An ocean means liquid water. Liquid water could host life. So the big million-dollar question for Europa is there life in that ocean? And in fact, the next mission, the one that NASA is working on now, it's just in the development phase, is called the Europa Clipper. And the Europa Clipper is going to study the surface of Europa in detail to try to see if there's a place that we could actually access that ocean and see what's in it. Ganymede is the largest moon in the solar system, and it's got this particular geology with these sort of folded ridges. It's very typical for icy moons in the outer solar system. And then there's Callisto, kind of boring, covered with craters, old as rock, older. In any case, it has the scars of everything that ever impacted on it in the last 4 billion years. Okay, that was our whirlwind review of Jupiter and prior to the Juno mission. So Juno, as you can see, is solar powered, and it is now in orbit around Jupiter. It's the first solar powered mission to go that far away from the sun. And it has 8 science instruments. It's spinning, which was actually kind of a challenge for building a camera, because putting a camera on a spinning platform is not exactly easy. We launched in 2011. It was a 5-year cruise to Jupiter. We got there on the 4th of July last year. And of course, you all saw the fireworks, right, to celebrate our arrival. To meet mission success, to get the data that we want to collect, requires 35 orbits. And they're 53 days long. And the science objective is really to understand the evolution of Jupiter, and thereby to also gain insights into the evolution of our solar system. It's the largest planet in our solar system. Of course, it's going to have a huge influence on what happens, or what did happen. And then that also gives us some clues about what's happening in planet systems around other stars. So here's a drawing of the spacecraft. Again, solar arrays. Altogether, the spacecraft is 66 feet long, and you can see the silhouette here of that person for size. So it's really quite large. Most of the instruments are around here, but there's a couple mounted out on other booms. And JunoCam is snuggled up right there, next to the body of the spacecraft. So we launched on a beautiful day in Florida. No hurricanes. It was great. Okay, so this orbit is really key to the success of the mission, to getting the data that we want to get out of the mission. And so we came in, so the Earth is way over here someplace. We came in from the Earth, and we went very close to Jupiter, and we were able to capture into orbit there. And now we are executing these big 53-day orbits. But the main thing is that this is a polar pass. So we are seeing that territory at the poles that had never been studied before. And that also gives us a whole new perspective on the magnetic field and the gravity field. So the types of questions that Juno is designed to address are things like, does Jupiter have a core? We don't know. Is it all atmosphere all the way down, or at some point does it become solid or liquid? We don't know. we want to understand more about its magnetic field. Its aurora are so powerful that we can actually see them from the Earth, from this Hubble Space Telescope. So we want to understand more about that. We would like to know how much water is in Jupiter's atmosphere. And with our microwave radiometer, we can sense to much greater depths and puzzle that out. But these science objectives do not actually require carrying a camera, a visible imager. And, but my boss, who is the principal investigator on this project, said, we are not going to Jupiter and not carrying a camera. We are going to have a camera. And so he decided that it would be a camera that was dedicated to outreach. And so he asked me to be in charge of it, and we decided that we did not want this to be a passive experience. We wanted people, anybody who wanted to take an active role, to have a way to be a part of our team. And so I like to say my team is the world. Unfortunately, I'm the boss of nobody. So when we were designing the camera, we said, okay, what is unique? And because we didn't have a lot of resources. We did not have enough mass for a big telescope, so we don't have the kinds of movies that Voyager and Cassini were able to collect. And, but what's really unique are the views of the poles. And so, and I want to point out something else. So that's our camera. And it's about this big, if you can see my hands. It's not very big. And it's actually quite heavy, though. If I were to hand you this sweet little camera, your hands would go like this because of all the shielding we had to put on for Jupiter's radiation environment. Another thing I want to point out, and you will see this from here on in my talk, I am putting the credit. So the pictures that have been processed, this is the name of the amateur who actually processed these two images, the South Pole and the North Pole, that we collected on Perijove 1. When I say Perijove, I mean closest approach. So so when you're building an instrument, you start out with, well, what do you want it to do? And that drives a lengthy requirements document, usually tens of pages. Because this was an outreach camera, I put 3 requirements and they fit on 1 page. And our camera was built by Mainland Space Science System. So the requirement was that when the spacecraft is over the pole of Jupiter, I want it to be able to take a picture of the entire pole. And so that means we have a 58-degree wide field of view. It's almost like a fisheye lens. This camera is mounted on a spinning spacecraft. So as the spacecraft spins, we build up signal. So we actually build up our picture a few lines at a time. I wanted red, green, and blue so that we could make color pictures. We actually added a methane as well. And I think that's it. That's basically, those were the requirements. Plus it had to survive. So because of this vision that we were going to really invite the world to be a part of the mission, and that we wanted to give people a way to participate, not just observe, we spent a fair amount of time thinking about what does it take to run an imaging experiment on a spacecraft. What's required? Well, you have to do some planning. You have some discussion. Now, up here I say voting, but in my life, in previous teams, voting is more like being in a conference room and arguing, maybe rather loudly. So voting is a nice way for the public to be involved. And then the final step is processing the data. We're actually working on a 5th step, which we're going to call analysis, but it's not quite done yet. So we developed this website with these 4 different ways